Hi, my name is Karsten Mckinney, and this is my ME3210 Project 1 about different manufacturing types. The manufacturing design techniques I decided to go over today are additive manufacturing, casting, decision matrix, also known as Pugh's method, water jet manufacturing, and lithography. Additive manufacturing is more popularly known as 3D printing, but it also has many various other uses. Its main uses are producing three-dimensional parts off of CAD drawings. It's used by dividing the CAD file into various layers and by building it layer by layer. When building certain parts, they might have to have support structures as they might fail otherwise, and those structures can usually be removed from the part. It has three different material classifications: liquid, solid, and powder. Additive manufacturing is mostly known for the fused deposition modeling using thermoplastics, which is in your usual um, commercial grade 3D printers, where they use a thermoplastic filament and build from there. But it can be used on plenty of solid materials such as metal, polymers, and even ceramics. It's extremely useful for cheap and rapid proof of function prototyping, as 3D printing can take within hours, or take within hours depending on how big or the size of the product. While it might not use the same material, it's great for, like I said, proof of function. And certain techniques have precision as small as a micrometer, and it can also produce parts as big as 6 meters, 6 meters by 2.3 meters by 1.8 meters. Also, commercial 3D printers allow for cheap part construction for the average person at home. The limitations of additive manufacturing are the removal of supports can often cause damage to the parts when finishing it. Poor design and model placement can cause large amounts of material waste. It's not the best for rapid mass manufacturing, as it is slow and it has such a small amount of area that it can actually produce the parts. But it's better for prototyping, as you're only making one or two, not trying to make as many. Often parts distort due to thermal stresses used to form parts, and often the parts need to be sanded as they can be rough depending on the precision of the machine. It's very important for a rapid prototyping, as you can make the 3D design and print within the same day. Prototyping from other tools and machining or whatever can take multiple weeks, as you might have to outsource it and can cost lots of money. As happened with my internship, it took 4 to 6 weeks for me to get the prototype, while 3D printing would have allowed us to get a proof of function and make more adjustments to the final design quicker. It allows and cheaper. It's important to me, and also allows for the cheap manufacturing of parts that are small in quantity, like such as your house making light switches or making switch frames, and it also just allows people to get their hands in engineering, no matter how expensive it is. The second process I'll be talking about is casting. Casting is the process of melting materials and pouring it into a mold where it cools and becomes solid. It uses various types of furnaces to heat the material into a liquid form, and additives called fluxes to keep the materials from reacting with the air or the mold walls. Molds are usually made from CAD/additive manufacturing, and there are lots of various casting processes such as continuous, strip, sand, shell, plaster mold, ceramic, vacuum, expendable pattern, and wax. Expendable mold permanent patterns are The expendable molds are made to be used once, but the casting can be continually reused. Expendable molds are usually broken off the molded part and cannot be used again. These main types of are called like sand casting, where you use sand as the mold, shell mold casting, plaster mold casting, and ceramic mold casting. Expendable mold, expendable pattern is when the mold and the pattern might be lost. So, like lost foam process, where foam is used as the pattern, and once you pour the liquid metal material, it usually melts and gets rid of the foam. Permanent molding is what is generally used for mass production, and it has a permanent pattern, and they are not destroyed once the material is poured into the mold. This is usable for mass production processes such as slush casting, pressure casting, die casting, centrifugal casting, squeeze casting, semi-solid metal forming, Rio casting, single crystal casting, and rapid solidification. Also, these casting processes are very capable for making alloyed parts and for making raw material parts such as sheets and ingots. Casting limitations. Metal contracts when it is cooling down and has to be taken into account for the tolerances. The initial investment for machines and permanent molds are expensive. The cooling process has to be handled delicately or parts can be brittled or cracked. Air bubbles have to be monitored for part defects, and parts have to have a finishing process as the cooled parts usually have rough surfaces. Casting importance. It's one of the earliest metalworking processes. It allows for alloyed parts to be easily made. It allows for very uniform and consistent parts. It allows complex parts to be made without intense machining. It's important for raw material creation and is great for casting parts that are made using CAD. The decision matrix. It's a tool used to compare different options and alternatives. It's a tool used to compare different options and alternatives and can be used in various different things, not just engineering and design and manufacture. Step one is to find the issue that you're trying to solve. And then step two is to have the alternatives, which can be the different solutions you are trying to use to solve the issue. Then you select the criteria that you that matter the most when trying to solve this issue, and then you weigh them in level of importance to how well they can solve the issue. Step five is to evaluate the alternatives based on this criteria, and then you multiply it based on the number you weigh it with versus how well it scores. And then once you use those scores, you use the grading to select the best option available. Capabilities. It is capable of comparing many alternatives. It helps to make a subjective argument more objective and allows multiple people's differing perspectives to be raised and weighed in a more objective manner. It is usable in many facets of life and can be used for many different options, such as work, which car I'm going to buy, lots of different things. Decision matrix limitations. The entire process depends on the user's knowledge, research, and discernment. It can fail depending whether or not they have the correct alternatives. It can also fail if you do not weigh the importance of the criteria correctly. Decision matrix importance. It's a well-established tool to use for making decisions. It's quite usable for many different decisions in my life personally, as I'm graduating and I want to decide jobs, what furniture I'm buying, all these different things, and it'll be useful for my future decisions. It's great for group discussions and group discernment, as you can weigh everyone's decisions in a reasonable manner. Water jet. High pressure fluid is sprayed through the nozzle to cut through different materials. There are 3 different types of jet versions: water, abrasive, and gas. Water is the usual method to cut through, and is the cheapest. Abrasives are when you add abrasives such as silicon carbide or aluminum oxide to the water to increase the cutting rate. And gas is when you add abrasives to a high pressure jet to cut through different materials. They have machines that can be used in 3 dimensions. It's eco-friendly and no heat is on the parts. It can cut through materials such as 25 millimeters and thicker and can be used on flexible material due to lack of deflection on the other pieces. It's safe as there's no harm material waste, and it has minimal burn on the produced parts. Gas jets can be used also in the general cleaning of regular surfaces. Limitations. Precision can only go up to the millimeter. Cutting speed drops significantly for metals. Gas jets can also not make sharp corners, tapered holes, and can cause airborne particulates and are not as safe. 3D manufactured parts can use CAD to be made. Great for sheet metal manufacturing. It's an eco-friendly manufacturing method, safe, and it can be great for mass manufacturing due to high speed and easily automated. Lithography. Uses various different techniques to implant patterns, large patterns on small surfaces. The 3 main methods are photolithography, electron beam, and X-ray lithography. First, the wafer is covered in photoresist to protect and clean the wafer. Then it's pre-baked to harden the photoresist, and after this, it is radiated to engrave the pattern onto the wafer. Then another baking process to solidify the substance is used, and then the engraved part is either filled with another substance or the wafer it's etched away. Finally, the photoresist is stripped away, and you have a usable wafer. Precision on electron beams can go as small as 2 nanometers and is used for precise line making on processors at big companies like Apple or Intel. It can create extremely fine details on these wafers. Lithography limitations. It requires large clean rooms, which are a large investment, and as the smallest particulate can contaminate the wafer. The equipment is very expensive, and it takes multiple pieces of equipment to produce the finished wafer. Lithography importance. It's extremely important for nano-manufacturing of processors. It's important to me as I work in a Georgia Tech Nanotechnology lab and work with these machines, and allows for the further advancement of technology with smaller and finer processors that continue to be made day by day. Thank you for your time. This is my report.